So in the last lecture, we have discussed about in the last lecture we discussed about the use case diagram. So today in this lecture we'll discuss about class diagram and other UML diagrams as well as. So in the past lectures and the previous lecture, we have talked about UML, and then we have discussed about use case diagram, right? So what is a class diagram? Certainly, its constituents are the classes. Okay, you will have certain number of classes. Okay, so each and every classes will have certain number of attributes and operations. And your class diagram actually describes the static structure of a system, because I told you. So the objects, they will not change over time. The the number of instances or the objects that will be, or the entities that will be part of a system will not change over time, right? So here that is the reason why it is a static structure of a system. It describes the static structure of a system, right? Now, so through this class diagram, we'll show how these classes are, related to each other. I mean, what relationship they maintain, and then what are different dependencies they have. So the first, relationship, that is generalization, and then we'll talk about aggregation, and then association, and we'll talk about dependencies. So when you say any class, usually, it's a um, it's a wrapping up of data and methods into a very single unit, right? And there are certain number of entities, and these entities will contain will have the similar features. Then that will be part of a particular class. The entities with similar features, right? They will be part of a particular class. And the features are attributes and operations. That is what you know, right? So classes are represented as solid outline rectangle with compartments. So here you will see there is a rectangle and with three different compartments. Okay. Now the first compartment, will be used to represent the name of the class. The second compartment will be used to represent all the attributes of a class. And the third compartment will be used to represent all of the operations of a class. Attribute and operation compartment are optional for reuse purpose. Okay, so they are usually optional. Usually because we are going to use, we're trying to reuse these classes, right? Through inheritance and all, right? So there it will be useful. That means what sort of operations you are going to inherit. I mean, you try to reuse. Okay, so these sort of thing, right? Now, this as I told you. So each and every class contains three different compartments, right? So the first compartment represents the class name. That means here, for a library automation software, let's say we identify a entity here, library member. Let's say, maybe a library member is a class here. Okay. So the name of this class is library member, right? So what are the attributes of a library member? So the library member will have a name, will have a membership number, will have some address, phone number, email address, and membership admission date. That means when he actually started his membership, and what is expiry date also, right? And what, the number of books may be issued. Okay, number of books may be issued. So these things, these are actually the attributes, right? So along with which, that particular class will have, these are different operations or the methods, right? Issue a book, maybe one method. Okay, so find pending books, he can always be able to see what are the books that is pending with the library member. Okay, that means he has to return to the library. He has taken some of these books, right? And they are pending with that particular library member, right? And find overdue books. I mean, there is a method through which you can always find uh, whether any of the books got some overdue. So then he has to pay for that. Okay, because let's say the library allows you to submit a book uh, after one month of issuing it. Okay, so in that case, so if the library member has not returned after the due date, so then there will be some overdue charges also. Okay, or you can say it can be overdue charges method, or it can be the function method through which you always be able to know whether the book uh, is due to return, I mean due for returning, or it is not due for returning. So that for that purpose this method can be written. You can think of like this. Okay, and return book may be another method through which you will be going to return your book, right? Find membership details, at any point of time you will be able to know the membership details, like the membership number, maybe any other admission date, expiry date, these sort of details whenever you wanted to know. So you can know through these particular methods. Now, so this is one class, right? So as I told you, sometimes you can have a only class name. Okay, or you can always add the attributes of that particular class, or you can also add the methods or the member functions, okay, of that particular class. Okay, so there are the three different representations. Now in a particular class diagram, so this so what you will see is, there are various number of such classes, and they will have some relationships uh, as well as some dependencies. So we'll try to represent all of them. Okay, now you can see here, you can always also specify your access. Okay, so access specifiers can be given through these symbols like plus minus. Let's say here member number name. So if it is a public, so I mean any, so that particular attribute is a public attribute, and the membership number, if it is a private one, that means it cannot be accessed by outside class. Okay, so that means it should be accessed through its object only. So then you can always represent through plus and minus. Okay, as well as also you can specify the type of that particular attribute, right? Like here in this case, member name can be a string, the membership number can be int. You can write like this also. Similarly, for methods also you can say through plus and minus, you can always say whether it is a public method or it is a private method. Okay, so you can always give your access specifier to attributes as well as methods. Similarly, you can also give mention the type of arguments. Okay, what sort of type, what type of arguments this issue book method is going to take. Okay, and what it is going to return also, that is also you can write. Okay, like let's say for example, issue book is actually returning let's say only a boolean variable, like whether book, whatever the book you requested, whether that, if that book is issued or not. If it is issued, then it should return yes. If it is not if it cannot be booked, then if it is saying false, something like this. Okay, in that case you can write always boolean, okay, before the issue book. Now there is a association relationship, okay, so which enable objects to communicate with each other. Okay, so usually binary, but more classes can be involved, right? So always we try to see, we try to see the association between two classes, but it is also possible with more number of classes. Okay, so like one object is going to talk to the other object, right? So they try to communicate. So that is what exactly association, right? So class can have relationship with itself. That means sometimes the same class can talk to itself also, right? Communicate to itself also. So that is what we call as recursive association. Okay. So the arrowhead used along with the name indicates the direction of association. So through a arrowhead, you can always say, so in what direction the association holds, right? And also multiplicity can be used to indicate the number of instances. Here in the next diagram, then you will be able to understand what it is, a multiplicity, but here it's a instances, the number of instances, right? So now you can see in this diagram, so now there are two classes, one is a library member and there is a book class. Okay, these are the two classes, so they maintain an association. Okay, now the arrowhead here, it represents in what direction this association holds. Okay, I mean, so now we can understand, right? And there is a multiplicity here in this case. So library member, after that you see the number one, and near the book class, you see the star. That means here multiple star represents multiple number of book instances. Okay, and one represents only single instance of library member. That means what it says. So exactly it says like multiple number of books can be borrowed by a single library member. This is what a single library member can borrow, a number of books. Okay, many number of books. Okay, so this is the way that you can always represent, you can give the multiplicity. That is what, so star represents multiple and one represents one. If it has two instances, then you can write 2, 3, 4, whatever may be the number, right? Now there is a aggregation relationship. So it all represents whole part relationship. Okay, I mean, so combining together certain number of classes, so they will become a whole. Okay, right? So and so this is what, okay, so you have certain number of parts and these parts will be aggregated to form a whole. Okay, whole system, right? So this is what exactly we call as aggregation, right? So represented by diamond symbol at the composite end. Okay, we'll see that example, but there are three different, there is a property, reflexive. So here aggregation doesn't, it cannot be reflexive. That means so the same class, you cannot aggregate the same class with itself. Okay, and it is not symmetry. That means it also does not hold the symmetric property. But it can it can hold the transitive property. Okay, we'll see through an example also how these properties are met or not. Okay, so now we can see here there is an example like here is a class, we have line and there is a paragraph and there is a document. So these are the three different classes. Okay, now you see paragraph to line, so they holds a aggregation relationship. That means what? So by aggregating certain lines, okay, we can lines of text. Okay, by aggregating certain number of lines of text, you can create a paragraph. Okay, that means there is a aggregation, right? Whole part. So certain number of sentences combined together to form a paragraph. Now, why there is a star? Because here multiple number of lines. Okay. Now they are actually aggregated to form a single paragraph. That is the reason why one. So now this aggregation will be represented through a diamond symbol. Okay. So now here, so certain number of lines of text combined to form a paragraph. Now similarly, certain number of paragraphs will be combined to form a document. Okay, so that means in a document there will be certain number of paragraphs, right? So this is aggregation, right? Now you can see whether the properties I told you like reflexive. Okay, that means can you see here anything like a text, a line will be aggregated with the line class? No, it cannot be, right? Because we aggregate different number of lines, okay, to form a paragraph, okay, right? But it is not like that. A line cannot be created by connecting certain number of lines of text. It is not possible. Okay. So I mean a paragraph cannot be created by aggregating many number of paragraphs. So this is not possible. Okay. Do understand? So this is the reason why. So it doesn't hold the reflexive property. Reflexive property means so always. So it is a recursive one. Same, same class never going to aggregate with itself. Okay. So that means it doesn't hold reflexive property, right? Now whether it holds symmetry or not. Okay. Now you see symmetry means what? So like here um, lines are combined together to form a paragraph, but paragraphs are combined not and if paragraphs are combined, then it cannot create a line. So that do understand? So if A to B holds, okay, then B to A doesn't hold here in this case. Okay, do understand? I mean by that is what, right? Now so that means if you have certain number of paragraphs, right, by combining certain number of paragraphs you can create a document. Okay, but but the same thing doesn't hold from the reverse side. Okay, so combining certain number of documents, okay, so you cannot create a paragraph. Okay, that is not possible. Okay, that is the reason why it all says like this. Now whether it holds transitive property or not, you see. So now what I said, so certain number of lines of text combined to create a paragraph, and similarly certain number of paragraphs will be combined to create a document. This is what we understand, right? Now you try to see, can I say like this, combining certain lines of text, can you create a document? Yes or no? Can anyone tell me? Combining
Yes,
certain number of lines of text, can we create a document or not?
yes, sir.
Yes, right. So that means, so here, so if it is something like this, okay, paragraph and paragraph to document, okay, these are the two relationships, separate relationship, then you can always have line to document. Okay, that means so it all so it supports transitive property. Okay, but it doesn't support reflexive as well as symmetry. Okay. Now this is what about aggregation. Okay, this is all about aggregation. Now there is a composition relationship. Now the composition is a stricter form of aggregation. Okay, it is a little bit stricter form of aggregation. That means it is also aggregation, but it is a very stricter form of aggregation. Okay, in which parts are existent dependence on the whole. Okay, so here it is something like this. Okay, I mean, when something is created by combining various parts, that is what we have seen, right? So certain number of lines will be combined to create a paragraph. That is what we have seen. Similarly, here is also, so certain number of parts will be combined to create a particular system. Okay. So now what it all says is when we have composition relationship, okay, that means if you segregate those parts, then those parts will not be useful. Okay, if you segregate those parts, then those parts will not be useful. Those parts value will be there only when they are aggregated together. Okay, that means now you can think of something like this. Okay, let's say you have a car, and a car is created by combining certain number of parts, like maybe the parts like this, you have a wheel, you have a steering, and you have a door, right? And you have a bonnet, so many things, right? So now, so combining all together, you can create a, you can that, I mean, life of those parts will be exist. Okay. Life of those parts exist when you combined all of those components together. That means it becomes a car, and everything has its value, right? Now if you separate them, like wheel will be separated, steering will be separated, and then the doors are separated, so in that case, so they do not have any life. Okay, so this way you need to think of, right? So that lifeline of all of the aggregated items are the same. Okay, so when the whole is created, the parts are created. When whole is destroyed, the parts are destroyed. That is what we say. Okay, now another example you can see here. So something like this: you went to a restaurant, okay, and you have ordered for certain number of food items, right? Now that order consists of certain number of items. I mean, the food items that you ordered, okay, through an order. Now, if you one of these items will be removed, then the order will be cancelled. Okay, if you, because as I told you, so either all of the items should be there to form a order, or the all of the items should be cancelled. Okay, so that means so this is the way you can think of. Okay, so now if the item is removed from the order, that means the order will be cancelled. Okay, if items are added, then there is a order. Okay, that means lifeline of order and item is the same. Okay, so then we say those classes, they holds they hold in a composition relationship. Okay. So now, so what is the difference between aggregation versus this, difference between aggregation and composition? So both represent part of whole relationship that you understood, right? Because you have aggregated, you have combined together certain number of components to create a new component, right? That is what you have seen, right? So that means that represents whole part relationship, right? So now when the components can be dynamically be added and removed from the aggregate, then the relationship is aggregation. Okay, so when you have when you maintain the aggregation, okay, so you can dynamically add certain items to the, you can add dynamically certain number of items to the order, or you can remove certain number of items from the order. Then that holds association. Okay, yeah, that holds aggregation, right? When components cannot be dynamically added or removed, then it is a composition. Okay, aggregation when you can, some of these items can be dynamically added and removed. Okay, so that means, so aggregation is not a stricter one, but your composition is a very stricter association. Okay, aggregation, right? Because if you remove one item, then whole order will be cancelled. Okay. And if you add also new item, then also you need to have a new order, not that the same order you can have. Okay. Right. So this is the way that you can think of, right? Any doubts of our students? Aggregation and composition?
No, sir.
Okay. Now the other relationship here is the inheritance. Okay. Now, so you can see here there are certain number of classes. Okay, one is a library book, is a maybe a base class, and you have certain number of derived classes. Okay, so now you can see here there is a library book class, and there is a issuable single volume book, issuable book set, there is a reference single volume book, and there is a reference book set. Okay, now these all of these classes, they are the derived ones. Okay, they are the derived ones for the class library book. Now you can see here there are two discriminators. One is issuable, the other one is reference. Now you see, so issuable single volume book, issuable book set. Now these are the two classes, right? So they are all issuable type. Okay, and there are two subclasses or the derived classes. Okay, they are of type reference. Now they can be grouped together also, right? And that group can be called as a partition. Okay, now here in this case you have two partitions, right? One is a issuable classes partition, the other one is a reference book set. Okay, so now you can understand this way, you can always give some discriminators. Okay, and also you can partition the derived classes or the subclasses into groups also, right? So this is what holds a inheritance relationship, right? And also you can write, you can always give separate generalization links, associations, right? Links, that is also possible. Okay, that means one arrow directly going from issuable single volume book, one arrow directly can go from issuable book set to the library book, one arrow directly can go from reference single volume book, and one arrow directly can go from reference book set. Okay, so this is also possible. That is also generalization. Okay, or that is also the inheritance. Okay, but when you see something like this, so if common, there are set of subclasses having the same discriminator, so then you can always draw this way. Okay. Now there is a dependency. Okay, that means there is an independent class and there is a dependent class. That means this dependent class is it is actually dependent on the independent class, and in that case you can have a dashed link, arrow. Now, so any doubts so far regarding the class diagram?
No, sir.
Okay. Now there is another diagram called as object diagram. So through object diagrams, we try to represent the snapshot of the objects in a system at a point in time. I mean, at any point of time, what are the different objects alive? Okay. At any point of time, what are the different objects alive within a particular system? So that will be represented through object diagram. Okay, that means here it shows the instances of classes, not the classes, instances of classes. Okay. Rather than the classes themselves. It is often called as an instance diagram. Sometimes we call this as a instance diagram also. Okay. Other than object diagram, we can also call instance diagram. Objects are drawn using rounded rectangle. So in the in case of class diagram, we have seen they are the rectangles, but in case of objects, so they are drawn using rounded rectangles. Okay, an object diagram may undergo continuous change as execution process, right? Because I told you, right? So different instances of a class can alive at different point of time, right? So that is the reason why you will have certain number of, as time progresses, when the system under execution, right? So you will find different number of instances of those classes, okay, associated with each other. Okay, so links may get formed between objects and get broken. So sometimes you will see, many objects, they form the association links, and also many objects they break the association links. So now here the object diagram looks like this. Okay, so in case of class diagram, that is a rectangle. Here you have a rounded rectangle. Okay, now for the library member, you see here is one instance. One instance is what? So the one instance here is Mrutyunjay. Okay, and what is the next number? B128. It is a library membership number, and then the address. Okay, and then the mail ID, and then the admission date. Okay, and the expiry date. Okay, so these are the actually, so through object diagram we try to show the instances. Okay, so try to show the instances of a particular class. Okay, that is what exactly part of a object diagram. So that means, so during execution you will be going to see many number of such instances. Okay, so getting associated with different instances of different classes. So is it clear so far, students, regarding this object diagram?
Yes, sir.
Okay. Yes, sir.
Okay. Now the other diagram here is a interaction diagram. So through interaction diagrams, what we try to model? We try to model how groups of objects collaborate to realize some behavior. Okay. So that means, so we try to see, as part of a particular use case. Okay, a particular use case, within a particular use case. So there, there will have many number of, objects, and they collaborate to realize that particular use case or the behavior of the use case. Okay, right? So I told you, so in order to accomplish any task, okay, so it is really required to have interactions between all of the objects that are part of that particular use case. Okay, so here, whenever you wanted to see these, the behavior, you wanted to see the behavior, or you wanted to realize the behavior of the behavior of the system, okay, or the use case. So usually we need to have a interaction diagram, right? Typically each interaction diagram realizes behavior of a single use case. Okay, so usually you always try to see that for each and every use case you will have at least one interaction diagram. Okay, let's say if the use case is very complex, so in that case you can have also sometimes you can have more than one interaction diagram to capture that particular behavior. Okay. So there are two types of use case diagram. One is sequence diagram and there is a collaboration diagram. Okay. So now so this name collaboration. So if you go through the recent UML versions, okay. So usually after UML 2, so before 2 UML 2, so as part of UML 1, actually we were saying this as a collaboration diagram, but after UML2, actually this is named as a communication diagram, not the collaboration diagram. Okay, but ultimately the concept is the same, only it has been renamed. Okay, so maybe if you're going through internet, maybe if you search something like this, sometimes you will be seeing instead of collaboration, you will see communication diagram, right? So, but actually it is the same thing, right? So there are two diagrams, right? So it's part of interaction diagram. These two diagrams, they are very much equivalent, but they try to portray different perspectives. So when you are going to design anything, so we need to have different perspectives, right? Then only you will be able to come up with a accurate design. So these perspectives are very much really important, okay, during design process. That is the reason why we wanted to see different perspectives of the behavior. Now the first one here is a sequence diagram. Okay, so through this sequence diagram, we'll try to see how different objects how these objects going to interact with each other so as to accomplish a particular task or the behavior of the use case. Okay, so here it shows interaction among objects as two-dimensional chart. So we'll see it uses some sort of two-dimensional chart sort of thing, right? So objects are shown as boxes at top. So in the top you will see the objects. Okay, and if object created during execution, then shown at appropriate place, right? So so during execution, okay, some of these objects created and some of these objects will be destroyed, right? So and that will be represented through this sequence diagram. So the objects existence are shown as dashed lines, that is the lifeline of a particular object. Okay, I mean so for how long, for a duration, if let's say that object is exist for a lifeline, so that will be represented through dashed lines, right? And object's activeness means that particular point of time the object is actually doing certain activities, right? So in that case, so that can be represented through a rectangle on that particular lifeline. So your lifeline is represented through dashed lines, right? And above which you will place a rectangle to show that the object is active at that particular point of time. Okay. Now the messages are shown as arrows, and these messages will labeled with the message name also, right? So message can be labeled with control information also. Sometimes you can also send some control informations, right? I mean, these objects can also send some control information also, right, to other objects. So two types of control information. So you can have sometimes conditions as well as iterations. We'll talk about them, right? Now, if we draw a sequence diagram for library automation system, okay, so here we draw a sequence diagram for what? For renew book use case. Okay, so I told you, so for each and every use case, so you will have an interaction diagram. That means you have a sequence diagram also, right? So that means, so here we have drawn this sequence diagram for the use case, I mean renew book use case. Okay, how to renew a book. Okay, so that is a renewing a book use case for which we draw a sequence diagram, right? So I told you in the above, so you will have all different objects, right? So the library boundary, that means it is the, you can think of the boundary of the library automation software, right? Through which the user is actually going to interact. Okay, a library member is going to interact, right, with the system. And there is a library book renewal controller. Okay, so it is the you can think of this particular object is usually takes all the responsibility of renewing a particular book. Okay, and there is a library book register. That means so you can think of there is a register in which you need to make all the entries. Okay, whenever any of these books issued from the library, or maybe it is returned to the library, so those things will be registered, okay, in a book register. So you have a library book register in which it has to be entered, right? And what is that book that you want a library member want to issue? And there is a library member also, because the library member is also an object. Okay, so now, so these are the 5 different objects that we have. Okay, now I told you, so the dashed line represents what? The dashed line represents the lifeline of that particular object. Okay, I mean this particular object is created at this point of time, and its life exists till that particular end, throughout this dashed line. Okay, so the lifeline of an object is represented by that dashed line. Okay. Now I told you, so on the lifeline there is a rectangle. Okay, on the lifeline there is a rectangle, so that will represent during this time the object is actually active. The object is very much active. Okay, now you can understand. So here also, so wherever in case of library member object, now you can see there, so for some amount of time the object is active, and thereafter it is not active, and again after some time it will be active for a short time, right? That this is the way that you can understand, right? Now because as I told you, it is a 2-dimensional chart, right? So that means, so you have a x-axis and you have a y-axis. Okay. So now you can see, so there is a renew book. This is the first arrow, and thereafter you have a second arrow, that is going to represent find member borrowing. Okay, and thereafter you have a third arrow. Okay, so the communications, whatever the interactions between the objects are following some sequence. Okay, now, so that means first these 2 objects are talking to each other, right? Library boundary and library book renewal register, and after that library book renewal controller object is talking to library member object, right? Now, and thereafter library book renewal controller object is talking to library boundary. Like when you coming from top to the bottom. Okay, so actually these are the messages being exchanged between the objects in this sequence order. Okay, okay, this is what exactly going to represent, right? So now here the first thing is that you wanted to, through the library member, so have a request to renew the book, for which the library boundary will talk to the library book renewal controller. Okay, send this message, right? And in turn, so your library book renewal controller will send a message to the library member object. Okay, so because the library book renewal controller should know whether he is a member of the library or not. Okay, so I mean, so the library book renewal controller should know whether who is that particular member actually trying to renew this book. Okay, so this is the reason why it is going to send a message to the library member. Okay, now after that what will happen? So once after knowing this, okay, so the library book controller, renewal controller will send back a message to the library boundary displaying the borrowing, right? He is a member actually, borrowing that, trying to borrow this book. Okay, so now after that what will happen? So now through the library boundary, so the library member can select certain number of books. That means the books that is selected, that will be sent to the library book renewal controller. Okay, that means so the book you wanted to renew, okay, so that will be selected by the library member through this library boundary. So then what, the books are selected, and those books are book selected will be sent, okay, to the library book register, because these are the books actually selected to renew. Okay, and then what will happen in turn, your library book register, actually, so book register is what? So there you going to make the entries of that particular book, right? But actually you need to see whether that particular book, what is that particular book actually, they wanted to renew. Okay, so in that case, let's say you have selected 4 books for renewing. So in that case, what will happen? So for each book, the library book register will send a find message. Okay, find a message to the book object. Okay, book object. That is the reason why here is a star represents. So star represent iterative things, I told you, right? So here, let's say you have selected only 1 book. In that case, you will have simply only find. But because there is a possibility that through the library boundary we can select 4 books to renew. Okay, so in that case, what will happen? For each of the book, this find message will be going. Okay, for the first book, find will go. For the second, find. So like that. Okay, so here, so the iterations will be represented through star mark. Okay, and thereafter, what will happen? The library book register will send a apology message to the library book renewal controller. Okay, saying that if the book is reserved, okay, if that book, whatever the book the library member wants to renew, if that book is already reserved, okay, if that book is already reserved, so in that case, that means condition. Here you have a condition. Condition is represented through I said you through square brackets, right? So here you can mention the condition, right? So the book is reserved here. Okay, so then though the book is reserved here, now it is sending back an apology message to the library book control. That means, so this book is already reserved, so you cannot issue it. Okay, I mean you cannot issue renew this particular book. Okay, so and then in turn this library book renewal controller sends back a apology message to the library boundary also. Okay, do you understand? Now what will happen after that? So the library book register, let's say if that particular book, after that, this library book register will send an update message to the book saying that this is what actually should be updated. Like updated means, this book is actually not issued because it is already reserved for some purpose. Okay, so this has to be updated in the book list, right? So that is the reason why you need to update that message after this. Okay, once this is updated, now this library book register will send back a confirm message to the library book renewal controller. That means it has been updated. Okay, and after that what will happen? The library book renewal controller, what it sends a message, so it will send a update member borrowing. That means it will have to update with the library member also, right? So in the library member so account, so it should also be updated. Okay, it should also be updated that this book cannot be renewed and it is not renewed. This is what will be updated in library member object also, right? let's say if that book is issued, then also it needs to update, right? So let's say you requested for the renewing. So if the librarian doesn't accept your request and instead says that no, this book cannot be issued, that means that should be updated in your account also. Otherwise, what will happen? It will show that it has been renewed. Okay. So as a result, um, things will need to be updated, right? Otherwise, it will be a problem. Okay, and the same way this library book renewal controller will also confirm. That means so finally it is updated with the library member and the message will be generated. So some display message will be going to the library boundary. Through that library boundary, it will be said that the this is what happened. Okay, so that means the information, I mean the renewal of book has been updated with every other objects. Okay, this is what some sort of message, right? Maybe you can say the book is not the book cannot be renewed because it is already issued. So this sort of message that you are going to give to the library boundary, right? So that is what you sending a confirm message also. You sending a confirm message to the library boundary. So this is the way that you can capture always any of this renew book, any of these use cases. Okay. So any doubts so far regarding sequence diagram, students?
No, sir.
So no one has any other doubt.
Sir, sir, while we are discussing about the class diagrams,
Yes.
so we didn't discuss about the static members, how to represent them, like we use underline, that sort of thing.
Yeah, that's fine. Okay. So here actually, I said in the as a class diagram. So basically, so we need to you need to have classes, right? So you need to have basic attributes and operations. If you want to say something, so because you see instances are represented through underline. Okay. So and then colon. So when you put a so before the colon. So if you write something, that will be a class, and after the colon it is a actually the instance of that particular class. Okay, so here we have taken the instances because the objects we are talking about, right? So that is the reason why it is underlined. Okay, clear? Is it clear?
Yes, sir.
Okay, so and even if you want to write your class name also, you can write the class name also. That is also okay. Okay, class name colon and then you give the object name and then you underline this. So that means it is a object. So here because the space is not there, so sometimes class name is removed. Okay, but even if you write the colon and thereafter the object name, that is also fine. Okay, so this is the object representation. Okay, is it clear now?
Yes, sir.
Okay. Now the other diagram here is a collaboration diagram. Okay, so we have talked about the sequence diagram. The other interaction diagram here is a collaboration diagram. So it shows both structural and behavioral aspects, right? So as part of your previous diagram, sequence diagram, we have seen the behavioral aspect, right? How the system is, how the use case is behaving. Okay, when different objects are talking to each other. Okay. So that is what we captured. Okay, if those objects are talking to each other by exchanging certain number of messages in a sequence order, okay, or in a order, then we have seen some behavior is observed, right? Now, through this collaboration diagram, not only we see this behavioral aspect, but also we will see something else, that is what we call as structural. Okay, so it has both structural and behavioral, but in the previous diagram that shows only behavioral aspects, right? So objects are collaborators shown as boxes. So here also you will have certain number of objects, right? And those will be represented through boxes. Messages between objects shown as solid line. Okay, messages is shown as a labeled with arrow placed near the link. Okay, So the same way as previously. So the messages are prefixed with sequence numbers to show the relative sequencing. Now there by default we have seen the sequencing, right? So when you coming from the top to the bottom in case of interaction diagram, I mean sequence diagram, so that follows a order, right? So that means first, in the previous diagram, you can see first renew book, and thereafter we have sent the find member borrowing, and thereafter display borrowing, right? Then select books. So that means they are following some sequence, right? So these messages are exchanged in some order, right? So in order to show the behavior, right? So by default it is understood, the sequence is understood through this representation, right? But here as part of collaboration diagram we will use some sequence numbers to represent, I mean to say that in what order these messages are exchanged. Okay, so now here it is something like this. Okay, so here also you have those many number of objects like library boundary, library book renewal controller, library book register, book, library member. Those are only the objects here also, right? And you can see here in this case, so whatever the messages that we have exchanged, right? So those messages are also exchanged here. Okay, I mean exchanged between, I mean between the objects, right? So first we started with the renew book. There also you see the first we started with the renew book. Okay, and then we find member borrowing. So now here the second one will be, so first the message between between these two objects are exchanged is renew book. Okay, and then second find member borrowing. Okay, so that means the message between library member renewal controller and library member, this is what the message exchanged. Okay, so similarly, so the whatever the messages we have exchanged, that is also represented. Now along with that you can see here there is a sequence number, one column. That means it is saying that this is the first message in the sequence exchanged, and then second message is exchanged is find member borrowing, and the third one is display borrowing, and fourth one is select books. Now here also it is showing the behavioral aspects is similar to the sequence diagram, but here it also shows the structural aspect. Structural aspect means, so which object is talking to which other object. So this is what exactly represented. Okay, now you can see, so this is library boundary is actually is associated with the library book renewal controller. Now library boundary is no way associated with the library member. So library boundary is no way associated with the library book register, right? And the library boundary is no way associated with the book. Okay, so that means, so we need to see that only these two objects, I mean these two objects going to, they going to exchange the messages, right? And library book renewal controller is associated with library book register, library member, as well as it is associated with library boundary also. So this is what exactly the structural aspects, right? So which object is going is associated with which other object. So this is what represented through a collaboration diagram. So this is what not represented as part of sequence diagram. Only sequence diagram shown that what are how these messages are being exchanged among the objects to to show the behavior of the system. Here we have seen that behavior as well as we have seen the structural aspect also. That is what the difference. Okay, any doubts of our student?
No, sir.
Okay. So I think I should stop now here. Okay, in the next lecture we will talk about the activity diagram and other things. Okay. So again, so you have tomorrow another lecture at 1:15, right?
Sir, extra lecture.
Yeah, extra lecture. Okay.
Okay, sir.
So because we are following the same time schedule for the extra lectures, but only I didn't take yesterday because of some issue. Okay. So tomorrow also 1:15 to 2 I'm going to take another extra lecture. Okay. And just I'm downloading the attendance sheet. Just give me a minute.
Hello, sir.
Yes.
Sir, doesn't the sequence diagram indirectly shows the interaction between any two objects?
That's very difficult to see there. You know, I mean, here you see the structural things. Now, library boundary is directly associated with this library book renewal controller. This is what you can easily understand. But there, it is very difficult to see that. Okay, so the library boundary, whether it is connected with the library renewal controller object or what, so it is quite difficult. Okay, because as of now you can see it's a very small diagram, so you can easily understand, because in a large project you will have thousands of objects, right? So and then it is very difficult for you to capture that aspect. Okay, so thousands of objects, so sequence diagram showing thousands of objects, so quite and identifying which particular object is associated with which one, so that will be very much difficult, right? But for a small diagram you can always see by seeing this sequence diagram, so you can say ki, yes, library boundary is also connected because it is sending a message to library book renewal controller, right? So it is fine. Okay, but in a large project actually you will have many number of objects, right? Sometimes it will happen that the sequence diagram will be drawn in thousands of pages. Okay. So that is what the difficulties are. Okay, is it clear?
Yes, sir.
But you have a diagram of something like this, collaboration diagram, so you can easily identify, right? So this part, library boundary and library book renewal controller, this part can be drawn in one paper. In the other paper you can draw library book renewal controller and library book register, this portion. Okay, and the second page you can draw like this. Then you can easily identify. But in case of sequence diagram, the arrows going from here to there, there to there, so that's quite difficult.